equal to 1 by m integral x dm. Substitute now here 1 by m integral, what is x? X is as it is x coordinate of the element. What is dm? Already we have calculated here, m by l dx. M is a constant which can be taken out of the integral. 1 by l integral x dx you will be getting. And this integral, this rod is between A and B ends. Length of this rod is L, x. All the rod which is lying between origin and L coordinate, in between only we have to consider the rod. Therefore, limits of this integration are 0 to L xm, that is equal to 1 by L into x square by 2, integral x dx is x square by 2, 0 to L. So 1 by 2L into L square, that is L by 2. Therefore, center of mass of a uniform rod which is aligned along x-axis with one end at the origin is located at the midpoint of the rod. So therefore, center of mass coordinate is L by 2 comma 0 when we choose origin at the end A. In case if the coordinate axes are chosen in a different location, say coordinate axes are like this, and the rod is located like this. Rod end A is not at the origin, only end at a distance L by 4 from this end, origin is located. So therefore, what are the coordinates of center of mass now? Center of mass is going to be midpoint of the rod. Therefore, coordinates of center of mass are, as per this diagram, coordinates of center of mass are L by 4 comma 0. Whereas in this case center of mass coordinates are L by 2 comma 0 because end A was at the origin, whereas in this case end A is at a distance L by 4 away towards left. Therefore, from the origin location of center of mass is L by 4 comma 0. Therefore, center of mass location not only depends on the mass of the bodies but also location of the individual particles, or where the origin of the coordinates, how the mass is distributed. This is for uniform rod, mass density rod. Then in case if it is non-uniform straight rod is there, what is the procedure to calculate locate the center of mass of such a system? Next one is non-uniform straight rod. Okay. This case, how to calculate the center of mass of a non-uniform straight rod? Is straight but non-uniform. What is meaning of non-uniform? Mass of the rod is non-uniform, distribution is not same throughout. The mass is not uniformly distributed on the rod. In that case, it is called non-uniform rod. So when it is non-uniform, then how is it? If it is uniform, it's a uniform distribution. For non-uniform, there may be many non-uniformities. How the mass is distributed? So for that, how the density, linear density is not a constant if it is non-uniform. When linear density is not a constant, how it is varying? So linear density of mass is no longer a constant. Is not a constant, it varies. Let us assume that in non-uniform rod case, linear density of mass is not a constant. Then how it is varying? Let it vary as a function of distance x from the end A. Let the rod be aligned along x-axis. Let the rod be aligned along x-axis. Rod AB, but linear density of the rod varying from the end A, otherwise it was constant in the earlier example. Now in this case, linear density depends on its x distance from the end A. Let us consider a rod where the linear density is varying like this, 1 minus 1 plus x by L, where L is the length of the rod and m is the mass of the rod. Total mass of the rod is m, total length of the rod is L, lambda is the linear density of mass is lambda naught into 1 plus x by L. If the density varying like this is given, how to determine the center of mass of such a rod? For that purpose, the procedure is same. Imagine the rod be divided into small elements. Consider a rod element of length dx situated at a distance x. Then first thing is we have to determine the mass of that element. So dm mass of the element is lambda linear density at that position, that is lambda x, into length of that element. Mass per unit length of that element into length of that element gives you mass of that element. Then how to calculate the total mass? Integral dm. Here what is lambda naught? Lambda naught is assumed to be a constant. Lambda naught is assumed to be a constant. So first of all, how much is lambda naught value? We don't know, but it is supposed to be constant given as per this. First we have to determine how much is lambda naught value. Integral dm is m, which is nothing but lambda naught. Lambda x is lambda naught into 1 plus x by L into dx. 1 plus x by L dx. Then this mass of this rod only lying between x coordinate 0 to L. Therefore, limits of this integration must be 0 to L. Therefore, this is lambda naught into, first integral is integral dx is x. Second integral x dx is x square by 2L. Limits are 0 to L. So, what you will be getting is lambda naught into L plus L square by 2L. So, this is 3L by 2, lambda naught is m. From this what we conclude is lambda naught therefore is equal to 2m by 3L. So, lambda naught value is 2m by 3L. That is what we have determined. But our problem is to determine the center of mass of such a rod. What is the procedure for center of mass? The same procedure. The formula used for only xcm will be there because it is lying on x-axis. Y and z coordinates are going to be 0. xcm is integral xdm 1 by m integral xcm. Substitute the values 1 by m integral x into dm. dm is lambda naught, we take out of the integral, 1 plus x by L into dx, x varying from 0 to L, because once again we are interested in finding out the mass distributed or center of mass of the system lying between the coordinates 0 and L. So from this what we get, xcm is lambda naught by m into integral x dx is the first integral 0 to L. Second integral is x square dx by L 0 to L. From this what we get, lambda naught by m integral x dx is x square by 2. Substituting the limits we will get L square by 2 plus x square dx is x cube by 3. Substituting the limits L cube by 3L. So one of these L's gets cancelled. What we will be getting is L square by 2 plus L square by 3, that is lambda naught into 5L square by 6m. That is xcm. But lambda naught we calculated as, how much is lambda naught we got? Some 2m by 3L. 3m by 2L. Okay, we'll first once again calculate lambda naught. Lambda naught into 1 plus x by L dx. Integral 0 to L is mass. So lambda naught into L plus L square by 2L is m. So therefore lambda naught is 2m by 3L. That we substitute here. So lambda naught is 2m by 3L. Substituting here x coordinate, xcm is 2m by 3L into 5L square by 6m. M gets cancelled, one of these L's. This is 5L by 9. So x coordinate of center of mass in this case, non-uniform rod, when the density is varying, linear density is varying like this with expression lambda naught into is equal to 1 plus x by L, we find center of mass is not lying at the midpoint, but it is a distance at a distance 5L by 9. It is more than the half. It is more than half the point. So center of mass is more towards the after the other half of the rod length. That is how we calculate the center of mass of non-uniform rod, straight rod.
డియర్ స్టూడెంట్స్, మెకానిక్స్ టాపిక్ గురించి తెలుసుకున్నాం కదా. మెకానిక్స్ టాపిక్కి సంబంధించిన సెంటర్ ఆఫ్ మాస్ గురించి కొన్ని అంశాలను తెలుసుకున్నాం కదా. రేపటి ఎపిసోడ్లో మెకానిక్స్ టాపిక్లో ఎల్ షేప్డ్ యూనిఫామ్ రాడ్ మరియు యూనిఫామ్ సెమీ సర్క్యులర్ ప్లేట్ గురించి తెలుసుకుందాం. ఈ కార్యక్రమంపై మీ సలహాలను సందేహాలను మాకు పంపాలంటే eclasses@KABTV.net కు ఈమెయిల్ చేయొచ్చు. టిల్ దెన్ కీప్ వాచింగ్ KAB టెలివిజన్.